In the previous video, we saw that compared to the true values, the predicted values using k-neighbors predictor were very constant along these horizontal lines. And the reason was because the scale for the y-axis in this picture is so much bigger. Like this space here represents so much bigger of a distance than this space here. So when you're using something dependent on distance, like k nearest neighbors, then this axis, this dimension, artist followers, is really dominating. So another way to look at it is see how this horizontal row is almost all blue. Okay, there's just this one red exception. And in this horizontal row that's really close to it, it's almost all red. Let's see if we can predict or if we can fix this problem by using StandardScaler. And I've imported that here from the pre-processing module. And while I'm here, let me get the columns that I've been using. So if you ever find yourself copy and pasting like a list like this very often, then that's a sign you're doing something wrong and you should really save it as a variable. So let me call this, how about numeric columns? Okay, these are the numeric columns we were using. And now, let's see, was the data frame called df3? I think it was. I think this is where we had restricted it to just certain chords. Okay, just like 4 different chords. Okay, and how do I use StandardScaler? Well, here's an example of what I want to use it on. So notice how these are all numeric. You can only plug numeric things into StandardScaler. So you create a StandardScaler same way you create a linear regression or logistic regression object by calling the class name and then parentheses. And here I don't need any inputs to it. And then let's do scalar.fit, which is like saying, learn what the distribution is for each of the columns individually. And now let's try scalar. You might expect it to be predict. Hey, but that doesn't exist for StandardScaler. It's called something else. It's called transform. And it's a little too bad that we lose the column names, but it's not going to matter too much in the long run. So let's call this, how about x scaled? And now let's make a new classifier. So k-neighbors classifier. And I'm going to use 4 neighbors just like I used up above. So k is going to be equal to 4. I don't know why the autocomplete didn't work, but I think this is how you call it. Okay, good. So now I want to fit using x scaled. And then using df3 chord. Oh, not crod, but chord. Okay, great. And now, let's see, was there already a prediction column in df3? I can't remember. So there was, but there's nothing in it, so that's perfect. So let's do df3 brackets pred. Okay, so I'm going to assign this prediction, and I'm going to assign it using the classifier dot predict. Okay, so this is like saying, use our classifier, our k nearest neighbors classifier, to predict what should go in this column. And so what it's doing is for each of the rows, it's finding the 4 nearest neighbors, and then it's using the chords for those 4 nearest neighbors to predict what the chord should be for this one. Okay, now let's try plotting it like before. And what I'm hoping is that it will look less steady than before. So it's still going to look kind of steady, but I hope, like, for example, these two that are really close to each other, there's more difference between them. It's not like almost all blues and then all reds right next to each other. So that's what I'm hoping for. And so let's see, instead of X, I'm going to call this df3. And I think that's the only change I have to make. And let's look at it. So it still looks pretty similar, like they're still fairly steady, but like notice there are a couple reds here in the second row, and this one that I keep pointing out, these two that are right next to each other, they have a lot more difference between them. And if we pan to the left and look at the range for like what distance is represented by this, well, I guess here it still looks the same, but it's using the scaled values, okay, for the predictions. So that's why it's secretly different. Like if I wanted to, I could say df4 equals df3.copy. Okay, and then let's do df4, those numeric columns from before, equals, and then did I call it x scaled? Yeah. So I'm like plugging that scaled data into df4. And now let me plot using df4 instead of df3. Okay, now you can see, I mean, it all looks exactly the same because it's not changing the distribution or anything. All it's doing is changing the means and the standard deviations. Okay, it's changing like the absolute scale, but the overall picture looks the same. So here we have like these rows that are right next to each other, but now they correspond to this scaled version of 2 and like 1.9. And so as like just one more example, let me look at df4 dot mean axis equals 0. This is like saying plug in one column at a time. And so notice the difference between some of these are like e to the negative 16, so that's very close to 0. Whereas this speechiness, notice that wasn't in my columns list, so that wasn't one of the ones that I scaled. So this is like 1.24 times 10 to the negative first, so this is like 0.124. Okay, and notice how speechiness was not one of the columns that I scaled. And if I were to do standard deviation, well, better not be zeros. Now it should be something else. Okay, we don't want it to be 0 because that would be like saying they're all the same value. And now you can see that it looks kind of random, but then there are a bunch of these that are really close to 1. And so those are the ones that I rescaled using scikit-learn's standard scaler.